Okay, an equilibrium problem. Let's write our balanced chemical equation. And our equilibrium constant expression. Okay, for our ice table, we need all of our quantities to be in concentration, molarity. So we're going to have to calculate that. CH4 and CS2 have the same number of moles, 1.00 and 0.25 liters. So we start out with 4 molar CH4 and CS2, 4 H2S, and H2. We start out with 2 moles of each in that same 250 milliliter container. So they have initial concentrations of 8 molar. Alright, so for our ice table, we're going to assume that the reaction proceeds to the right. So we would lose X and 2X of our 2 reagents, gain X and 4X of our products. So we have our equilibrium is initial plus the change. Alright. So here we can input our expressions. Alright, and our equilibrium constant is given to us as 0.036. Now this is one equation with one unknown. We could solve this if we had several days to work out the algebra. Fortunately, we're given some information here so we can generate a value of X. We know that the equilibrium concentration of CH4 is 5.56. And since in our equation it's equal to 4 minus X, we can calculate our value of X. However, we see that our value of X is negative 1.56. Now, what this means, since we can't have a negative concentration, we don't have antimatter, what this means is we've assumed the wrong direction. What's happened is the reaction actually proceeds to the left. Okay, but that's not a problem. As long as we're consistent here, we're going to be able to get our correct values. So we have equilibrium concentration of CH4 is given to us. That for H2S is equal to 8 minus 2 times x, which is 8 minus 2 times a negative 1.56. 2 times a negative 1.56, a negative subtracting a negative, it's going to be plus and adding a positive, so that ends up being 8 plus 2 times 1.56, or comes out to be 11.1. CS2 at equilibrium is 4 plus x. And that ends up being 2.44. And finally for H2, equilibrium is 8 plus 4x. It's 8 plus 4 times a negative 1.56. .76. Okay, so even though we've assumed the direction incorrectly, that the reaction proceeds, it's not a problem. We still can get to appropriate answer as long as we are consistent.